Hello distinction students, I hope we are all doing fine. So in this video, we will look at a very interesting topic in integrated science, growth and development. The interesting part about this video is that there are examinations past paper questions of which I have provided solutions. This video is a revision based on what we have been doing in class. It's your tutor, Mr. Peter, and without waste of time, let's begin. So in this unit, I'm going to define the term growth, then we'll go ahead and look at phototropism and geotropism. So what is growth? So growth is the permanent increase in size of an organism. So remember what I always say, when you're studying, then you come across some difficult words which you are unable to understand. Don't ignore those words. Try to find the meaning of those words. By doing that, you make it easy to understand what you are studying. So let's say, for instance, in the definition of the term growth, let's say we don't know what the word permanent means. So if you don't know what the word permanent means, then you won't know more about growth. So in this video, I'm also going to help you break down difficult words so that you find it easy to understand what I'm trying to explain. So permanent in simpler terms simply means something that cannot be reversed, or let's say something that will last for a long period of time. And for you to understand, let me give you this practical example. So let's say you plant a mango tree, and then after some years that mango tree will grow big, but that mango tree can never go back to the way it was previous years, which means it's permanent. A bigger tree can't grow into a smaller tree. That's permanent. So permanent simply means irreversible. So the other importance of breaking down difficult words or large words is that you are able to come up with your own definition. So let's say growth. Growth can also be defined as the irreversible increase in size of an organism. Those two definitions simply means the same. I have just replaced permanent with irreversible, and permanent and reversible simply means the same. So now we move to phototropism. So phototropism is the growth of the plant towards light. Phototropism is the growth of the plant towards light. I remember giving a practical example in class where I said, let's say you have a sealed box. Okay, let me just draw it. Let's say this is your box, and then you have a plant inside the box. This box must be sealed, and then let's say you make an opening at this position. This simply means that light will enter the box at this position. When you put this box on the sun, light will enter the box at this position. So if you come to observe this plant, let's say after some weeks or after a month, you discover that the plant will bend in this direction. The plant will bend towards the opening that you made. Why is it that the plant is bending towards the opening? It's because the plant is following light. The plant is following light. We know that plants survive through the process of photosynthesis, and photosynthesis cannot take place in the absence of light. So plants need light in order for them to manufacture food. So plants will follow light. That's phototropism. And then we have two types of phototropism. We have positive phototropism, which is also known as positive phototropic, and we have negative phototropism, which is also known as a negative phototropic. So positive phototropic is when the plant grows towards light, and then negative phototropic is when the plant grows away from light. For you to understand, let me also draw. So the first box that will be on the left side in red ink will be representing positive phototropic, and then we have a plant here inside, and then let's say we have an opening at this position, and then the box that I'll draw in blue ink on the right side will represent negative phototropic. And then we have a plant here also, and then we have an opening here, and then this is negative this is negative phototropic. So we start with positive phototropic. So we know that when you place this box on the sun, light will enter the box at this point, which means light will be at this point. So what will happen after some weeks or after a month? This plant will bend towards light. When the plant bends towards light, then that's positive phototropic. That's positive phototropic. And then on the other box, we know that when we place this box also on the sun, light will enter at this point. So which means we have light here. And then after some weeks or after a month, when you come to check on this plant, you discover that the plant will grow in this direction. So when the plant grows away from the direction to light, away from light, then that's what the negative phototropic. It's growing away from light. We know that light is at this position, but the plant grows away in the opposite direction to where light is. Then that's negative phototropic. So we now move to geotropism. We move to geotropism. So geotropism, this is when the plant grows either towards or away from what? From gravity. So geotropism is when the plant grows either towards or away from gravity. We have two types of geotropism. We have positive geotropism and we have negative geotropism. They can also be called geotropic and geotropic. So we have positive geotropism. This is when roots grow in the same direction as gravity. And then we have negative geotropism. This is when the plant roots grow in the opposite direction as what? Gravity. For you to understand, let me also give examples to geotropism. The first diagram here on the left side will represent positive geotropism. Let's say this is the ground. Let's say this is the what? This is the ground, and then we have a seed. Let's say you drop a seed here, and then water has been spilled at this position. Or let's say this point is moistured. This point is what? Moistured. And then the other diagram that I will draw in blue ink on the right side will represent negative geotropism. Let's say you also have, let's say, a seed. You have dropped a seed there, and then water has been spilled at this position, or this position is moistured. So what you discover after 3 weeks, we start with positive geotropism. What you discover is that the shoot will grow in this direction, but the roots will grow downwards. So when the roots grow downwards, they are responding to gravity. When they grow in the ground, they are responding to what? To gravity. Then that's positive geotropism. The one that we are saying is when the roots grow in the same direction as what? As gravity. So when the roots grow in the ground, then they are responding to what? Gravity, and that's positive geotropism. And then we go to negative geotropism. So negative geotropism, you discover that the shoot will grow in this direction towards light, but the roots won't grow down. No wonder we are saying that negative geotropism is when the roots grow in the opposite direction to gravity. We know the ground is gravity, but the roots won't grow down here. Then that's what? Negative geotropism. And this plant cannot survive because the roots needs to grow in the ground to get what? Water, which is very much important for what? For plants. So we have answered we have looked at growth, we have looked at phototropism and geotropism. I hope now you know how to differentiate between positive and negative, both phototropism and geotropism. We move to the next unit. So in this unit, we are looking at a nutrient and a fertilizer. But before I define a nutrient, I'll define nutrition. So nutrition is a process by which living organisms obtain and utilize food for growth. And then a nutrient, this is a chemical present in what? In food. So nutrients are divided into, we have non-mineral nutrients and we have mineral nutrients. So let me just give you a hint on non-mineral nutrients and mineral nutrients. So here I'm saying that Non-mineral nutrients, these are nutrients which are in form of gas and they are found in the atmosphere. Examples include oxygen, carbon, and hydrogen. These are gases and they are found in the atmosphere, but they are nutrients, which means they are non-mineral nutrients. And then we go to mineral nutrients. Mineral nutrients, these are nutrients which are found in the ground and they are classified or grouped in three. And then before I explain here, let me differentiate macro and the micronutrient. Make sure you pay attention on this. So macro, macro, these are nutrients which are needed by plants in large amount. These are nutrients which are needed by plants in large amount. And then micro, micro, these are nutrients which are needed by plants in small amount. So examples of primary macronutrients include nitrogen, phosphorus, and potassium, which are abbreviated as NPK. Which are abbreviated as what? NPK. So these abbreviations are very much important. You need to know what the letter NPK stands for. You might be asked in an exam, what does the letter P stand for? You say P stands for phosphorus, and then K stands for potassium, and N stands for nitrogen. Then we go to secondary macronutrients. Remember, macro needed by plants in large amount. Examples of secondary macronutrients include calcium, magnesium, and sulfur. And then we go to micronutrients. These are nutrients which are needed by plants in small amount. Examples include copper, zinc, iron, and chloride. Then we are done on what? Nutrient. So what you need to know on nutrients is that you need to know the difference between non-mineral and mineral. So we have said non-mineral, they are found in the atmosphere, those are gases, and then mineral, they are found in the water, in the soil. Okay, and then mineral are also grouped in three: primary, secondary, and micro. And then you also need to know the difference between macro and micro. The difference between macro and micro nutrient is that macronutrients, these are nutrients which are needed by plants in large amount, and then micronutrients, these are nutrients which are needed by plants in small amount. We jump to the next point, which is a fertilizer. So what is a fertilizer? So a fertilizer is a substance that contains plant nutrients needed for plants to grow. So fertilizers are added to soil in order to increase the soil fertility. So we have two types of fertilizers. We have organic fertilizer and inorganic fertilizer. We have organic and inorganic fertilizer. So organic fertilizer, these are natural fertilizers. And examples of organic fertilizer, those are fertilizers or compounds that contains carbon. And then inorganic fertilizer, these are artificial. These are chemical or these are man-made fertilizers. And then examples include ammonium sulfate. Apart from ammonium sulfate, we have ammonium nitrate and the urea. Those are examples of inorganic fertilizer. So now we are done now with this unit. I hope now you know what a nutrient is, you know what a fertilizer is. So we jump to examination past paper questions. Quick update. Did you know that grade 9 online classes are ongoing? Yes, Knowledge World Academy has now introduced grade 9 online classes, which will begin on the 18th of January 2024 at an affordable fee of only 149 kwacha a month. Now back to the examinations question. We now answer examinations past paper questions. Question 1. The diagram below shows a young uprooted plant from Katongwe village garden. Question 1a. Identify the three regions of growth in the plant above. So the answer to question A is shoots, stem, and roots. So here what you need to know is to understand the question. What is the question asking you to do? So the main keyword here is growth. So growth is the permanent increase in size. So it simply means where will the plant grow? Will the plant only grow to the roots only? No. When the roots grow, the shoot will also grow, and the stem will also will grow. No wonder all the three parts of a plant will will grow, and that's the answer to question A: shoots, stems, and roots. So now we go to question B. There are three main nutrients that are good for plants, and these are commonly referred to as NPK. What does the letter NPK stand for? So you can pause this video, try to answer this question, and then compare the answers. So N stands for nitrogen, P stands for phosphorus, K stands for potassium. So state the effect on the plant when any of these nutrients is lacking. So lacking, question C is kind of related to question B. Question B says we have these nutrients here: nitrogen, phosphorus, and potassium. And then question C now says, now suppose nitrogen is lacking, what will happen to the plant? Suppose phosphorus is lacking, what will happen to the plant? And suppose potassium is lacking, what will happen to the plant? So when nitrogen is lacking, the plant will have slanted growth and yellow leaves. And then when phosphorus is lacking, the plant will have poor roots and purple leaves. And then when potassium is lacking, the plant will develop yellow leaves with dead spots. Then you have answered question C. We move to question D. Give the name of the compound of fertilizer where you can get these nutrients. So question D is saying, where can we get nitrogen? Which fertilizer provides phosphorus? Which compound of fertilizer provides potassium? So nitrogen is obtained from urea, phosphorus is obtained from ammonium phosphate, and potassium is obtained from potassium nitrate. Then you have answered question 1 on example 1, as simple as that. We move to the second examination past paper question. Now we answer the second examination past paper question. So you can pause the video and try to answer the same question, and then you compare the answers at the end. So question 1, a young shoot was exposed to light from one direction as shown below. Question A, explain the growth of the shoot after a few weeks. So the arrows that you are seeing on the board are simply showing the direction of light. So it was more like light was at this position, and then light was hitting the shoot at this point here. And then question A reads, explain the growth of the shoot after a few weeks. So when a shoot is exposed to light coming from one direction, where do you expect the plant to grow? So of course the plant will grow towards light. So you can answer saying after a few weeks the plant shoot will bend towards light. Where light is what? Where light is coming from. Then you have answered question A. We answer question B. What do you call this condition of growth? This condition of growth is called phototropism. Question C. If roots of the plant above were exposed to unconditional light, do you expect them to respond in the similar manner? Give reasons. So question C is opposite to question A. They are saying, let me just draw it. They are saying, since in this diagram we are having the shoot outside which are exposed to light. Now question C is saying, now suppose the roots were the ones exposed to light. Are they going to respond in the similar way the shoot responded to light? So the answer is no. Why? Because roots are not phototropic. Their growth is not does not depend on what? On light. Then we answer question D. Explain the importance of the part of the plant responding to what? To light. So question D is simply saying, why is it important for a plant to respond towards light or to grow towards light? And the answer to question D, you can say, when the plant shoot grows or bend towards light, that will help them get enough or maximum light needed for photosynthesis, which is the manufacture of food. So that's the answer to question 2, question 1. So I hope the answer that you answered are quite similar, or they are exact to the answer that I have provided. Let's now answer the last exam past paper question. Okay, we answered the last examination past paper question. You can pause the video as well. So an experiment performed on rice plants grown in different cultural conditions shown below to study some mineral deficiency symptoms common to plant. So before you attempt answering questions, you need to know what the word deficiency and symptom mean. So deficiency simply means something is not enough or when something is lacking. And then symptom simply means when something is lacking, how will it appear or how is it going to look. So having information about deficiency and symptom, then you can attempt answering these questions. Question A: what do you understand by the term mineral deficiency? So I have already answered this question. Mineral deficiency is not having enough mineral in the soil, or when the plant is not having minerals. That's what it means. And then we go to B. What would be the deficiency symptoms observed in plant X, Y, and Z when left in this condition for 3 weeks? So for you to answer question B, we go to the diagram. We have plant X. Plant X here is lacking nitrogen. Plant Y is lacking magnesium, and plant Z is lacking phosphorus. So here they are simply saying now suppose nitrogen is not enough in the soil, what or how will this plant look? Why am I saying how? Because of the word symptom. It simply means how will it look when something is not enough. Deficiency. I've explained these two words. You can repeat this video on deficiency and symptom. So when nitrogen is lacking, the plant will have slanted growth and leaves will turn yellow. We have slanted growth and the leaves will turn what? Yellow. The reason why the leaves will turn yellow is that nitrogen is responsible for formation of what? Chlorophyll, a green pigment which is present in what? Chloroplast. And then when plant Y is lacking magnesium, plant Y will have pale leaves and sometimes develop reddish or purple spot. And then when plant Z, which is lacking phosphorus, plant Z will have poor roots formation. So if you remove this plant from this cylinder after 3 weeks, you discover that the roots won't be okay. Why? Because phosphorus is lacking, and phosphorus is responsible for proper roots formation. Then you have answered question B. We answered the last question. From the study above, what is the function to plants of nitrogen? So what is the importance of nitrogen? So nitrogen is responsible for production of protein as well as the chlorophyll. It helps in the formation of proteins and the chlorophyll. And then phosphorus is needed for roots development, proper roots formation. So that's all about this video. I hope you have understood everything that we have talked about this video. So the importance of videos is that you can repeat the video several times until you get the concept. So that's all about this question. Alright, now we come to an end to the grade 9 online tutorial video. Thank you for watching and continue studying hard. And remember what I said in the first part of this video, that whenever you're studying, then you come across some difficult words, don't ignore those words. Try to find the meaning of those words. I assure you, you find it easy to understand what you're studying. So it's your tutor, Mr. Peter, and see you in the next video.